Hi there, friends. It's Mrs. Romero here for science, and we are going to do lesson 2. Last week, you had Miss Sutherland, and she taught you about different materials and how to observe them. I remember we were looking at the materials that were in the file for Pepe, the missing dog, and we will have to see how this can be connected. So here is the Matter Mysteries hotline. Driving question number 1. What are the properties of different materials? This is our distance learning lesson, part 2. We're going to click start lesson and we are going to watch this video together. So grab some popcorn and get ready for the show.
Welcome back, science investigators. Last time, we began testing properties of mystery materials to help find Pepe, the missing dog. I hope he's okay. Time for a quick recap. There are properties that can be easily observed, such as size, like when we use the tools to measure length and weight. We also observe color with our eyes and texture with our hands, when we felt to see if the material was rough, smooth, or soft. Well, today, we are going to investigate some properties that are not as easy to observe. These are electrical conductivity, thermal conductivity, and magnetism. In a moment, we'll head back to the Twig Science Lab to conduct some more tests. But first, conductivity is the ability to flow through a material. So what does electrical conductivity mean? Yes, it will test whether electricity can flow through the materials. Can you figure out what thermal conductivity would mean? Correct. We are going to test to see if heat will move through the different mystery materials. Think about walking barefoot on a sunny summer day. What happens when you walk across grass? Not so bad, right? But what happens when you walk barefoot across a paved road? Ouch! Those are hot! The pavement on the road has the property of being a good conductor of heat. The grass does not share this property, so it's not a good conductor. And then there's the property of magnetism. This is a magnet. How can I test if something is magnetic? That's right. If the magnet is attracted to or repelled by the material, then it's magnetic. Let's test 2 metal containers of mine. First, this tin container. The tin container attracts the magnet to it. And how about this aluminum container? Fascinating. This aluminum container doesn't have the property of magnetism. Wow. Before we head over to the Twig Science Lab, we need to talk about how scientists carry out their tests to ensure that they are fair tests. What comes to mind when I say the word fair? Think about 2 baseball teams. Would it be fair to let one team have 9 players, but tell the other team they can only have 5 players? No, of course not. Fair means to not give an advantage. What do you think it means to carry out a fair test? Well, if we're going to test 2 toy cars to see which one rolls faster down a ramp, we would want to make sure that both cars were tested the same. We would have to start each car in the same spot on the ramp and let them go the same way. Fair and square. In the Twig Science Lab today, we will be using a circuit like this one for our first test, electrical conductivity.
So just a little pointer. Last year we had cars that we made and tested fairly, and we did conductivity with circuits. So you guys are totally prepared. I'm gonna stop the video here and we're gonna see what's next.